Is Anita's hand pointing you've ever done? Anita's pointing you've ever done.
Pressure. That is a pretty tall order though.
Now, as Michael's doing this, okay, Michael's going to do it himself here, and you guys are going to compare your answers. Think of how awful this would have been under chapter 1. Like, this would have taken you a huge amount of time, right? It probably would have taken me 5 pages to do this by limits. Because to get the purpose of how these things are done.
Just to make us feel good.
One lesson, we can move on.
It's just to make us feel good, right?
No, because to be perfectly, one of the reasons I want you to do it is because we're going to get to all the algebra skills you use, you're going to have to use again throughout this course, okay? Because the first chapter is just algebra, that's all it was, right? So those messy limits, rationalizing, and all that stuff, okay? Please don't write on my desk. But the idea is though that, yeah, all the stuff in the first chapter was to make sure you could rationalize, solve it, simplify all that stuff. And starting in about Tuesday is when that's hitting again in this. So, that good? Anyone confirm or deny that?
Yeah, what?
All good?
What is
I love it.
the top right?
That's a one. That's supposed to go.
Okay, guys. So the question was, the question was, what is this? I don't really know, but if you think of the derivative of this bracket, okay, the derivative of x plus 9 is just going to be basically 1. The derivative of x is just turns to be 1. Okay. All right, good. Example 3, C, whatever. 3? Okay, I have C on my thing. I'll call it example 3. Okay. Okay, after this, actually I have 2 more examples, then I will. Squared, yes. Whoops, this should be a squared here, sorry. That should be a squared. There we go. I can't frame it. Okay? Good?
Yep.
Okay, so do your best. And then I have 2 more examples here, and then we're going to start with. Because there's some good discussion here. Okay, so the question was, should I factor this one? And I'm going to say no. Why is it not probably to my advantage to factor this? The more brackets. Right now, we only know how to take the derivative of something with 2 brackets, right? Like that's what our thing that we proved there. So, and this we'll get to in the future examples. Even if you have 3 brackets, you got to FOIL that one set the way it works right now. So it's in the form of just 2 brackets going together. Okay. So if you're sitting there at the back, make sure you do this derivative right now. Do your best. Okay. Okay, so what you're going to do, just one thing at a time. So the first one's going to be the derivative of this one, which shouldn't be that bad. They're all polynomial stuff that we're doing here right now. Okay. Again, can someone from the back row be brave, please? Why is the back row so quiet? Someone from the back row takes the derivative of 1 plus 4x squared. Nate, what's the derivative of 1 plus 4x squared? 8x, good. And this looks like my first question I wrote with 2 boards here. Can someone from the front row take the derivative of 7x squared minus 3x squared plus x, please? What does that turn into? Someone from the front row, go ahead.
21x squared minus 6x.
Plus 1.
Oh,
The derivative of x
yeah.
changes the line, right? Minus 6x. All right. Now there will be some contention over. Can I please do this, guys? Okay. I'm glad that you're feeling good about this so far, but we still got a lot to cover here today. Okay. There will be some contention on what I'm going to say next. Some people will say, Mr. Salad, you should be able to leave it like that, and I say, no way in heaven will that happen. The reason is, very, very soon we're going to be doing algebra with this, so I'm going to want to solve when that equals 0. Okay, so you're going to have it FOILed out. We will be actually doing like derivatives, like a fractional derivatives and stuff, so you're going to want to factor things and cancel them. So I do actually need to take the extra 2 minutes of my life to FOIL everything out. Can I get a person from the middle row to FOIL out the left-hand side? You should be happy I chose the left-hand side because that was significantly easier. Just some middle or person do the left-hand side. Oh my goodness, come on guys, please. You're tall enough for 2 rows, go ahead, Matt.
56x to the 4
Yes.
minus 24x squared plus 8x squared.
Okay, you guys are lucky that Matt saved you. Someone in the back row, foil out the right-hand side, please. Matt, you're not tall enough to do the back row too. Somebody else, sorry Matt. Somebody else, please.
4x to the power 4 minus 24x cubed plus 4x squared plus 21x squared minus 6x plus 1.
I didn't hear what you said, so I didn't hear what you said, so I'm just going to write it
Okay.
out, okay?
Awesome.
Does that sound right? That's what you said in a different order?
Yeah.
I think, right? Yes? Okay, I'm going to combine it all together here. I'm going to pretend like you guys are in grade 9 again. I'm going to collect like terms. I know you guys are all professional mathematicians, but I'm going to take the time here. Is that right? 130 was that 140x to the 4? 48 minus 23. No, it's not right. Minus 48x. Plus 33x squared. Someone confirm that for me, please? I think that's right.
Yes.
Okay, now this is the fun part. In calculus next year in university or 2 years from now, depends when you're going. You're going to have to go from here to here, right? Right, and that's the hard part, right? That's what makes calculus different when you go backwards. We're not going to deal with it right now, okay? Because I don't want to scare you guys, okay? But next year, that's called integration. So if you have older brothers and sisters, like Christina does, who get to integration and they say that's awful. Okay, what I was just saying to the class was what it is going from the bottom here backwards. Okay, every mathematical operation can be flipped, right? So that's just not. Yeah, I'll leave that. Okay, I want to do one that's actually challenging for a change here. Example 4. Are we okay with this? I know I went through that quickly. Can everyone close their eyes again, even you? Tyler, close your eyes, please. Okay, good. Can you raise your hand if you're feeling good about that last example? Even though it was tricky. Raise your hand if you had a little bit of difficulty but can confident you could do it now. Okay, raise your hand if you had difficulty and you're confident you couldn't do it now. Okay, good. All right, example 4. Sorry if you're still writing, Tyler. Can I get rid of this? Yes? Yeah. Okay, so I'm going to do one that's actually a little bit of a challenge here right now. I'm going to give you the first step. After this, we're going to do word problems for us today. Example 4 says,
Challenge me to a duel.
hey, don't challenge anyone to anything.
You don't have to remember the duels?
Okay, don't even go there with me, Michael, because I will outdrill anyone in this class right now, I guarantee it. Yeah, I think everyone in this class. Okay, this question looks scary.
I think it looks easy.
Okay, the hint for this one is I gotta do with the square. What do you do with the square? Write it out twice and then do it, okay? So we're gonna say f of x, here we go. F of x is equal to x minus 3 root x times x minus 3 root x. We will learn on Monday how to deal with exponents. Okay, that's part of Monday's lesson, okay? But we don't know how to do that yet. Right now we gotta do this the old-fashioned way and foil it. Don't foil it out. So now we have 2 things for a product, right? So derivative of one, derivative of the other, and then foil it out. You can do it. Matt, do you brave?
The derivatives would be the same.
Michael, no hints. Okay, I'm gonna pause this and give you guys a chance to try it. It's gonna be this. What's root x mean again? X to the power 1 over 2. Okay, and that's you have to remember for these. Right? Is that fractional exponent is okay to go to. Okay. Harry, what's the derivative of x minus 3 root x, please?
1 minus 3 over 2 x to the negative 5.
Second board. Okay, and Harry's exactly right here. What I'm going to do is change all those square roots so just to fractions, just because I like fractions better than square roots. Okay, the nice thing is you're going to have the same thing. Okay, both brackets are going to be the same, so you really only need to FOIL once, so we'll just come back to it again. Okay, so can somebody FOIL that out for me here, please? I have to say this is on my face. Please, can someone FOIL for me? I gotta go back to Spider-Man, guys. Please, you guys are all brilliant. You know, it's not out at 99 on the midterm here. You guys are all brilliant. How do you do this? Ral, go ahead.
X minus 3x 1/2 minus 3 halves x to the half plus 9 halves. And that's like in brackets with the 2.
Awesome. Plus
3 halves, 9 halves, yeah. Those are the terms.
and then this is plus the same thing, right?
Yeah.
Okay, most will do the same thing.
The second 3 is 3 halves. It's minus 3 halves x.
This one here?
Yeah,
All right, you're right.
and
Sorry.
I didn't combine them.
Sorry. This is 9 over 4 then. Okay. That's 9 over 2. I'm going to combine like terms finally, so I'm going to get 2x. 3 minus 3 is negative 6 minus 9. X to the 1/2 plus 9.
Yeah.
Can someone confirm that for me? Confirmed? Please confirm.
The last term, negative 3 over 2x minus 1/2 times negative 3x 1/2 is 9 over 2.
Yes, positive 9 over 2. Because x to the negative 1/2 times x to the 1/2 is 0, right? No, 0. Because like you're adding the exponents when you're multiplying them, right? So it's going to be x to 0, so it's just positive 9 over 2. And I see a lot of staring at the board here, which is good, better than staring at your phones, okay? We're good now? Sort of? Michael, I know you're good, stop nodding. Anybody else? I want to make sure everything else is good. Michael, but I probably didn't want to judge. Michael, sorry that I checked. Okay, let's start to do word problems here. I'm going back to grade 10. I apologize if none of you were in my grade 10 class, so I didn't teach grade 10 back when you guys were there. So here we go, example 5. I'm going to say, at the Raptors game, we're going to say 175 bottles of water are sold for $2 each. I know, it's a lot more than that. For every 15-cent drop in price, 10 more bottles are sold. A, model this with an equation. If you were in my class in grade 11, you definitely saw this. 100% guaranteed. I think probably Mr. Walter must have done something similar. In grade 10, I did put this on this is like the hardest question in grade 10, okay, because it's going to be a quadratic. It's an application quadratic, right? Okay, what's x going to be in this case?
Price?
Nope.
Number of price drops.
Number of price drops this is going to be. So we're going to say let x equals the number of price drops. And I'm saying let R of x equals revenue. Okay, I would like you guys to silently think of an equation for this. Let's actually just go back to grade 11 here, because it's one of my class, helps people out. In English, what does revenue equal? Let's say you're selling bottles of water at the hockey game or the basketball game. How much money are you going to make? How would you figure it out? Yeah, okay, so it's going to be for this, revenue is going to be like the price of one times your sales. Right, so initially here, if I have 175 bottles of water and I sell it for $2 each, I'm making $350. Did we get the logic for that? Nate, do you remember these at all or not really? Yeah. Okay, so let's think of how we deal with the price. If you think of this like slope from grade 9, what's the starting price for water? $2. How much does it change each time? 15 cents. Which direction? Upwards or downwards? Downwards, okay? So I'm going to say for my price is going to be 2 minus 0.15x. Okay, hold on a sec here, please. Stay with me here. So what we're going to say, can I please talk? You're starting at $2. Each time we're going to drop 15 cents. What is my starting number of bottles that I'm selling? 175. How much am I going up by each time? 10. So I'm going to recall this. 175 plus 10x. For those of you that were not in my 3U class, is this coming back at all? Do they do this in Mr. Walsh's class?
So you do those three-step equation, like we learned about half-lives.
Yeah, half-lives are different. We'll worry about half-lives later.
Equation that was like base value and then price it progressively goes down by and then over time.
No, we'll deal with that one after, right? We'll deal with, this is going to be a quadratic, hopefully. This one should be. Right, yes? No, it's not in the head. I know the people in my class are not in the head. So anyway, this is quadratic. You're starting and going up, one's going down. I'm not going to tell, we're short on time today, so I won't tell. If we have time at the end, I'll tell all about my supply and demand stories and Cabbage Patch Kids and all that stuff, okay? Not right now. Okay, so I want you to find, for part B, is it going to be find R prime of x? I'm going to slow down here. I'm going to ask for a volunteer in about 60 seconds here. Now you can file this out, but I'm going to hope that you don't for this question, and we'll do this without